I am an artist. I work mostly with traditional media, drawings, paintings, that sort of thing. But I've dabbled in programming for about as long as I can remember. I started out making mods and small plugins and add-ons for games and things that I liked to play as a kid. For me, the programming side of things and understanding how all that worked was purely a means to an end. At that point in my life, I had no interest in understanding at a conceptual level what was happening behind the scenes under the hood of my computer. So for someone who's approaching it from that perspective, you get really, really used to things like error messages and computers crashing and programs crashing and generally making a huge mess of things. Everybody who's used a computer has an experience with a computer not doing the thing that they want it to do. And it's really easy to chalk this up to computers not understanding or even actively disobeying the instructions that we're giving to them. I recently had a revelation about this a couple years ago when I saw a fantastic cartoon by Zach Wiener of Saturday Morning Breakfast Cereal. And the first panel of this comic kind of shows the way that we tend to think about our relationship to computers. They're almost these magical machines that you can try to tame, but you can never really control them. They're, at the end of the day, just going to do what they're going to do. Anybody who's ever yelled at their computer when it auto-completed something incorrectly or deleted the last 4 hours of your work knows exactly what I'm talking about. But the reality is a little bit more complicated. I love this line. Computers suck because they do exactly what you say. And this is something that intellectually we know and understand. We know that computers are just machines that you put in input and they give you back some kind of output. And they do so with perfect consistency and logic. And everything that's an error is really a miscommunication between the user and the computer. Of course, this is a small consolation to me when I logically and consistently order the deletion of the last 4 hours of my work. So I think this highlights an interesting disconnect between the way we think about digital spaces, digital files, things that exist on computers, and the way computers actually process them. I propose that glitch art, which is art that utilizes the aesthetic effects of data being bent or broken or misinterpreted, can help bridge this gap and help us better understand what's actually happening in computers. So let's rewind a little bit. Back before any of this digital stuff, back when it was just art, not glitch art. So this is a painting, fantastic painting by Seurat. Seurat was a painter that lived in the late 19th century. And this painting is of a river, and you can see there's some grass and a tree and a person and a rowboat. And Seurat does something kind of interesting with this painting, and he's definitely not the first to handle paintings this way. And there are many, many, many others that were doing it all over the place. But I think this makes a good example. So instead of just putting paint on the canvas, pushing it around till it forms the rough shape of exactly what it's representing, he's done something a little bit different, and he's handled paint as a medium in its own context and for its own purpose. So what do I mean by that? Well, you have these dabs of paint, say on the shadowed part of this tree trunk up here. You have these dabs of paint, and they're not simply representing the color of that tree trunk. They also exist as independent entities, as brushstrokes. His technique of touching the brush to the canvas gives them a life of their own, of the three-dimensionality and physical presence of the paint being something that's valuable in and of itself, in addition to the trunk of the tree that it's representing. So essentially what Seurat did is he embraced the medium of painting, the paint, the paintbrush, the canvas, and he highlighted that for its own purpose and in its own context. So how can we apply this to digital images and digital art? Well, first we have to think about what is the medium of digital art. It's not super difficult. It's data, right? Ones and zeros. Of course, they don't look like this in your computer. They actually are just millions and millions of capacitors that either contain a charge or a 1 or a lack of charge, a 0. But this will do for our purposes. So when you think about a digital image, I tend to start by thinking of it almost as a photograph, as a physical object, but it's just on the computer somewhere else that I can't really manipulate it like a photograph. But that's not really true. It really just exists as these ones and zeros. And anybody who's had even a little bit of education about computers intellectually knows this, even if we don't really understand the full implications of that. But one of the interesting things about ones and zeros is that really what a computer puts on the screen for you to look at is just the way that it's interpreting those ones and zeros at any given time. There's no reason that ones and zeros that make up an image have to be interpreted by your computer as an image. So let me give you a little example of that. On the left is a photo that I took a couple months ago, and on the right is the same photo interpreted as text. All I did is I opened it up in a text editor, and it looked at all the ones and zeros, and it only knows how to take bytes of data and turn them into text characters. So that's what it did. And this scrolls, by the way. There's a lot of data packed into this image. The only difference over here is instead of representing a pixel and the properties of that pixel, over here it's drawing a character, and a different character depending on what the byte would have been in the original image. Well, if you can open an image as text, it stands to reason that you can edit an image as text. There's no rule that says you can't. What I'm about to show you is an extreme example using a slightly more advanced algorithm, but one that essentially just interprets this abstractly as text and then performs operations like changing a letter or switching a letter around. And it does this over and over and over again and creates an animation out of it. So here it goes. So that's the sort of effect that you can get. And there's no equivalent to that in painting or drawing or any other medium. It's leveraging the very nature of digital images to create the visual and aesthetic effects. And it looks really weird, but I think it looks kind of cool. So let me show you a couple other examples of things that you can do when you start thinking about images as they actually exist, as data. This is a photograph of myself from a couple years ago. Like everything else, it just exists on the computer as ones and zeros, which means you can open it like this and see a whole lot of text. So you can take that text, and what I did was I just opened it up and I copied large portions of the text and pasted it and shuffled stuff around, just like I was writing an essay or editing my resume or anything like that. And I only spent a couple minutes on it, not like the tons and tons and tons of work and time that went into the previous one you just saw, but I got something kind of interesting. Maybe not the most impressive picture in the world, but everyone's got to start somewhere. Then once I started thinking about it like this, and I thought, well, I can interpret it as text, but remember, the base existence of this image isn't text. That's just another way to interpret it. It's ones and zeros. So if we can interpret it as text, we can interpret it as other things too. So this program is called Audacity, and Audacity is a sound editor. So what I did is I imported the file you just saw into Audacity. And this blue bar that you're seeing over there is actually it turning that data into a waveform, just like you would see on a readout of a song or an MP3 or something like that. Of course, it probably doesn't sound very good. You can actually listen to this. I've done it. It sounds like a lot of horrible noise, but nonetheless, it is possible. So what I did is I said, well, okay, if I can open this image as a sound file, I should be able to manipulate it as a sound file, right? I can do audio effects. I can do other sorts of transformations to it that have nothing to do with its existence as an image. They're just interesting things that I can do. So I actually selected a portion of it, and I applied an echo effect. And that's what I got on the right. Again, maybe not the most impressive image in the world, but I think it looks pretty interesting. Now, if you can interpret images as text, or images as sound, or images as whatever the heck you want, it stands to reason that you can go backwards, right? All we're doing is putting ones and zeros in context that they weren't meant to be viewed in. It's not any property unique to images. So this is Walter Benjamin's essay, A Work of Art in the Age of Mechanical Reproduction, reproduced as RGB pixel data. Now, I could say that I took that essay and used it to generate this map. But in some sense, it's actually more accurate to say that this map is the essay. The data is the same. It's all the same. The only difference is that the program that's loading it only knows how to draw pixels as RGB color image. So this is really different from the way we're used to thinking about images. You know, if you have a file that's of a photo or something like that, I tend to want to think of it almost as like a physical object, something I could put in a drawer, only it's on the computer, so I can't really interact with it in 3D space. But really, once you start thinking about it in terms of ones and zeros, a whole lot of possibilities open up, and it totally changes the way that you interact with files on your computer. And with so much of our life being wrapped up in digital spaces these days, it seems to me that it really changes the way we think about a significant portion of our lives. Now, there's a lot you can do with glitch art. Glitch art is not something that's totally, absolutely new. As long as there have been computers, there have been people making things kind of like this. It goes way back, and there's all sorts of debates about who was the first glitch artist and all sorts of things. But I wouldn't be up here if I was just trying to encourage you to look at glitch art and go to museums and go on the internet. What I want you to do when you get home is be inspired to take files that you have and take your data and push it to the limit and see what you can do with it. Why does it break when you change this but not when you change that? Why does this totally distort the image, and this thing really doesn't make that much of a change at all? And when you do that, something strange happens, and you start to see the digital space in a new light and a new context, and you start to relate to it in a way that has more to do with what the images and things fundamentally are, and less the sort of analogs of the real world that they're approximating, not necessarily even well. So that's what I want to talk to you about today, is pushing things, breaking things, and seeing what happens. And I think if people do that, it can totally change the way they relate to the technology that they use. Thank you.